Today's session will be on sequencing problem. We have 4 cases of sequencing problem, and we are starting with the fundamental case, which is case 1, where we have n jobs. All those jobs are to be processed through 2 machines. So we are bringing upon a practical case from the production floor. There are 6 jobs which must go through 2 machines, A and B, in the order AB. Processing time in hours is given below. See, the below table mentions there are 6 jobs, J1, J2, J3, J4, J5, and J6. And there are 2 machines available, machine A and machine B. Now, each job takes a specific amount of time on each machine. For example, J1 spends 8 hours on machine A, J2 spends 10 hours on machine A, J3 spends 11 hours on machine A, J4 spends 12 hours on machine A, J5 16 hours, J6 20 hours. Similarly, J1 spends 7 hours on machine B, J2 spends 5 hours on machine B, J3 spends 0 hours, J4 spends 14 hours, J5 spends 3 hours, and J6 spends 9 hours. Now, our job is to identify an optimal sequence and elapsed time. So there are 2 problems associated with this. One is identification of an optimal sequence. Secondly, the total elapsed time which a production manager require at minimum. Fine. So we'll start with the algorithm which helps us to solve sequencing problem is known as Johnson and Bellman algorithm. Sometimes it is also known as Johnson algorithm. Now, Johnson algorithm moves in 2 steps. Step 1 talks about finding optimum sequence of jobs, right? Now, let us move forward and try to find it out the optimum sequence of jobs. Calculate, there are 6 jobs, 1, 2, 3, 4, 5, 6. So I am drawing a column table of 6, 7 rows. Now let me take only 6 rows. 7 rows are not required. Now see, go to your table which is given in your problem and identify the least number given in the table. So the least number is 0. Now see, 0 is for job 3 and for machine B. If it is for machine B means the second machine, then you have to enter from the bottom. If the number is from the first machine, then you have to enter from the top. I'm just adjusting. Now since 0 for J3 and it is for machine B, so J3 will be written from the bottom. And once you have written the job, you need to cancel it. I've just taken cancelled it, right? Now that means in our table J3 does not exist anymore. Now from the remaining table, find it out next least value, which is your 3. It is for J5 and it is for machine B. So since it is for machine B, the entry will take place from bottom. So I'm entering J5. Again, once you have written J5, cancel it. Now J4 does not exist anymore for us. Next, find it out next least possible number, which is 5, and it is for J2 and it is for machine B. So the entry will take place from the bottom. I am writing J2. Let me cancel this once again. So J2 is cancelled. Now next least number is 7. It is for job 1 and again for machine B. So the entry will take place from the bottom. So J1 and cancel it again. So I have cancelled J1. Now you have J4 and J6. So the least value is 9, which is for J6 and again for machine B. So cancel it. So J6 is being cancelled and it is entered from the bottom. Now the final and the last one is J4 and you have only one slot remaining, so it is J4. I cancel it as well. Cancel. So you do not have any other jobs to be entered in the queue. So this is your optimum sequence. Let us call one more thing. Suppose any of the two jobs have the same possible value. Like suppose you have identified 3 and you get 3 somewhere else as well, right? So arbitrarily you can choose any of the jobs to be entered, but precisely we prefer to take jobs which come at first. So if you are having a tie between J5 and J1, try to choose J1, right? So we are done with our optimum sequence, which is J4, J6, J1, J2, J5, and J3. Our next job is to step 2. So step 2 is time calculation. Time calculation. Right? I'm just bringing down this table so that we need not to scroll again and again. I've just mentioned it here. Right, and I don't require this cut parts. So you need to draw one more table. Now the table, how many columns does that table have, right? So we need to start with jobs. The first column will be job. Second column will be for machine A. Third column will be for machine B. Fourth column will be for machine idle time, right? So we have 4 columns: jobs, machine A, machine B, and idle time. Now machine A will be split up into 2 subcolumns: start and finish. Machine B will be split up into 2 columns: start and finish, and idle time will be split up into 2 columns: A and B. So all put together we need 7 columns. So I'm inserting a table with 7 columns, right? And we require 6 plus 2. Just merge this, merge cells. I'll merge these two, merge cells. I'll merge these two, merge cells. I'll merge these two, merge cells. And let me put everything into center position. So let me go up. This is for jobs. This is for machine A. This is for machine B. This is for idle time. Now here we'll write start. Here we'll write finish, again start, finish. This is for machine A, this is for machine B. So jobs. Now, this is our optimum sequence, right? So our jobs has to be in this sequence only. Now, see, every process start with 0. So the first element in the first machine start part has to be 0. Now see, this is start point for J4 and J4 is spending 12 hours on machine A. So 0 plus 12, it will finish at 1200 hours, right? Now once machine A finishes job 4, then only it can start job 6. Therefore, it will start with 12. Now go to J6 and in machine A it is spending 20 hours. So at 20 it is 32 hours. Follow the same logic. Machine A will start job 1 only when it has finished job 6. So it will start with 32 and job 1 is spending 8 hours. So it is 40 hours. So J2 will start at 40 hours and J2 will finish at 50 hours. Now J5 will start at 50 hours and J5 will finish at 66 hours. Last, J3 will start at 66 hours and it will finish at 11. 66 plus 11 is 77 hours. Let us come to machine B. Now we need to understand that one job first enters into machine A, then only it can go to machine B. So job 4 first finished its functions with machine A, then only it can enter to machine B. So it is finishing with machine A at 12 hours. That is why it is starting with machine B at 12 hours. Now see, job 4 in machine B is taking 14 hours. So that means it will finish at 26 hours. Now machine B is finishing job 4 at 26 hours, but job 6 is making available. Job 6 is available only at 32 hours. So that means machine B has to wait and it will start at 32 hours. So 32, job 6 is 9 hours. That means 41 hours. Now see, job 1 is ready to be processed by 40 hours, but machine B is not ready. Machine B is only ready at 41 hours. So machine B will accept job 1 only at 41 hours. Now 41 hours, job B is spending 7 hours. So 41 plus 7 is 48. Next, B is ready at 48 hours, but J2 is available only at 50 hours. So machine B will start at 50 hours. Now job 2 machine B, so 55 hours. It is ready at 55 hours, but job 5 is available only at 66 hours. So it will start at 66. So job 5, 66 is 69. Similarly, it is ready at 69, but job 3 is available only at 77 hours. So it will start at 77 hours, but finish at 77 hours. Now let us see idle time. Idle time is a time during which a machine is not working and it is keeping quiet, right? So see, machine A has started at 0 hours, finished at 12, so there is no idle time. Started at 12 hours and finished at 32, again no. Finished at 32 and started at 32, there is no idle time. Finished at 40, started at 40, no idle time. Finished at 50, started at 50, again no idle time. Finished at 66, started at 66, again no idle time. Then finally, it is finishing all the jobs at 77 hours and the entire system is running up till 77 hours. So there is no idle time either, right? So one more. Coming to B. See, machine B has to wait till J4 is supplied by machine A. So therefore, it is keeping quiet for 12 hours. Next, machine B was ready at 26, but machine A supplied job 6 at 32 hours. So again, it was keeping quiet for 6 hours. Next, it is finishing at 41, it is starting at 41, so there is no idle time. Finishing at 48, but starting at 50, so 2 hours. Finishing at 55 and starting at 66, so 11 hours. Finishing at 69 and starting at 77, so 8 hours. Now the entire system is running for 77 hours, so there is no idle time for last one, right? So this is dot. Now, we were supposed to answer total elapsed time. So total elapsed time equals to, always look for the last machine and the last finish time. So it is 77 hours. It means all the jobs will be completed in 77 hours. Now, idle time for machine A is 0 hour. Lastly, idle time for machine B equals to, you need to add all these. So 12 and 6, 18, 20, 31, 31 and 8, 39 hours. So it is 39 hours. Right? Now this is the case 1 for sequencing problem. We have 3 more cases to be discussed that will be discussed in the subsequent lectures. For any further query, you can contact me on arg.srkr86@gmail.com. Thank you.